This video is about the repeated squaring algorithm, an efficient way to calculate the modular when the dividend is a big exponentiation number. In the case shown, a, b, and c can be large numbers. A to the power of b can be a real large number, which the normal number types in programming languages cannot handle. Think about the question, do we have to calculate the exponentiation result to get the remainder? The answer is no. Actually, that's why we need the repeated squaring algorithm. We can apply this algorithm to forbid getting real large numbers and save a lot of time in calculation. If you do not know this, follow the video, you will find that this algorithm is pretty simple. Before getting into the algorithm, we need to understand two basic facts. The first one is about modular multiplication. Look at the formula. If you are unfamiliar with this, you can pause the video and write it down. To keep the video simple, I'm not going to prove it. Actually, this formula is not limited to two numbers. You can have multiple numbers in the brackets and the new formula is still valid. Again, try to remember this, since this will be important in the algorithm. The second basic fact is about binary number. It's a basic computer science knowledge. We can write decimal number in binary. We can also write binary number as sum of a series of power of 2. Look at the example. That's all about the second basic fact. A quick review. We need to have these two basic knowledges to understand the algorithm. Now, let's begin our main course. I'm not going to use mathematics formula to introduce the processes. Instead, I'm going to use this example shown on screen to demonstrate the processes. I recommend you writing down the whole processes while watching the video. It will really help to understand the whole thing. By the way, to show you how big the number is, if you solve this by brute force, this is a result of 591 to the power of 369. That's the reason we are using other ways to avoid this. The first step is to break the exponent to the sum of power of 2. 369 in binary is 1, 0, 111, 000, 1. The sum of power of 2 is another way to express it. From our last step, we can break the problem into this. If you don't understand at the first time, you can write it down on the paper. Now, we are going to use the first basic fact. We can write the whole thing into this. There are a series of parts multiplied together. We can start to calculate one by one. The process is simple since we can always use the result from a step before. I'm not going to read it here. You can write the first 3 steps down to understand it. Finally, we'll get a list. Some of the numbers are not needed in the next step because their exponents are multiplied by 0. To give you a review, this is where we were before. Notice how some of the exponents are multiplied by 0. We do not need them in our next step. Now we have the operation. And another list we got. Combine them together, we are making a huge progress. You can see that the operation has been reduced by a lot. We can continue to make it simpler by dividing them into 2 parts. Multiply the numbers by groups using our first basic fact. Finally, the dividend is reduced to 4,617 multiply 5,625, which is really simple now. The final result is 6,219. In Python, you can use the power function to get the modular result to testify the answer. If you are interested, you can implement the algorithm using your chosen programming languages. That's all for the video. Thanks for watching.